Hello guys, welcome back to my tutorial. Myself Farzana, and in today's session we are going to discuss about data augmentation. Before we dive technically, let's start with what is data augmentation, how it really helps and how it overcomes the challenges when we work with image data set. In computer vision, we deal with different problems mainly related with images. Image classification is one of the tasks in computer vision where machines are now capable of doing classifications more accurately than humans in the recent years. But the main challenging part is volume of data. In this session, we are going to check how data augmentation is really going to help with volume of data. And the next challenging part is whenever we train the model, we always face either overfitting or underfitting. We are going to check how data augmentation helps to reduce the overfitting in the model. But what is overfitting? When we found a good result in training data and a poor accuracy in the test data. Whether data augmentation helps with the lacking of data is for sure. How? By creating new data based on modifications of our existing data. The next question is whether it's a pre-processing or post-processing, right? Data augmentation is a pre-processing technique because we work on the data to train a model. The parameters supported are horizontal flip, vertical, rotation, zoom in, zoom out, cropping, color variation, shear. So whenever we found that there is a lag in the image dataset, by using a data augmentation, we can create n number of images to train the model. By doing a small hands-on, we will understood what is the benefit and what is the main reason behind these data augmentation techniques. To do this, we have to import the method ImageDataGenerator. How ImageDataGenerator really works? It accepts a batch of images which is used in training. It takes the batch and applies series of random transformations to each images. What is the series of random transformation? These are all the transformations for the particular images. Then it replaces the original image with randomly transformed batch. Then finally it trains the neural network on randomly transformed batch data and not on original data. What is this not on original data? We will understand once we're done with this hands-on session. To start with, it's a pre-processing technique. So we have to import tensorflow.keras.preprocessing.image and the method for this is image data generator. Then to convert into array, we have to pass image to array, then loading an image. For our current example, we are going to pass all these parameters with these values. We can also change with the different values and we can check how it really works. To do this, we have to import with the method image data generator and finally assigning it to a variable which is pred_gen. Sorry. The next step is we have to load the image. For that we have to pass load_img. So today we are going to check how we are going to do an augmentation with the predator. To convert an image to an array, we have to pass image to array for the mathematical calculation behind. Then we are reshaping it. Before executing this final step, I want to show the folder predator. Currently the folder is empty. So what I'm going to do is I'm initializing the value of I which is equal to 0 and I'm passing a condition for this input image which is nothing but pred_img_array and saving it to a directory which is nothing but a directory folder name is predator and saving an image with the predator and the format is jpg. So let's execute this one. Boom! Once we executed, we got 14 counts of image. Why 14 counts? So once we're done with this, we are incrementing it to 1. Once it reaches the count of 14, then we are exiting from this loop. Even we can extend the size based on our requirement. So by doing this, we can find the shapes of the images are with different shapes and different sizes. I mean the picture of the content. But if you notice one thing, the main image, this is not reflected in the augmentation part. So by this time we know that the reason, whenever we are training with these images, we can found that it is just a front and centered one. When the image is towards a left or right, or it's pointing towards an upside down or towards a corner, means our training data set, our test data set will get failed. That is the reason we are doing a data augmentation, that too with the very minimal lines of coding. So the final conclusion is, with the data augmentation, it really helps in regularization part as well as in generating the data. I hope the content is really useful. If you like the content, please do like, share, and don't forget to subscribe. Catch you soon in the next session. Till then, Farzana signing off.